Hello everyone. Today we are looking at GATE Chemical Engineering question number 31 from GATE 204654. Consider steady state diffusion in a binary A, which is nothing liquid but at constant temperature and pressure. The mole fraction of A at two different locations is Na2 by Na1 into 100, which is nothing but Na1 be the diffusive flux of A calculated assuming B to be non-diffusing, and Na2 be the diffusive flux of A calculated assuming equimolar counter diffusion. The quantity Na1 minus Na2 by Na1 into 100 is dash rounded off to one decimal place. So this is from the concept of diffusion from mass transfer. And the reference NPTEL lecture series for this can be found in lecture 4 of week 2, Diffusion Mass Transfer in Mass Transfer Operations 1 by Professor B. Mandal, Department of Chemical Engineering, IIT Guwahati. So here we have two liquids A and B at two different locations. So the distance between these two locations is given by delta Z. And let's write the given data for us. So we have XA1, which is the mole fraction of A, is 0.8 at location 1, and XA2 is the mole fraction of A at location 2 as 0.1. So we need to find Na1 minus Na2 by Na1 into 100. So Na1 and Na2 are nothing but the molar fluxes of A at two different cases. So Na1 represents the molar flux of A assuming B to be non-diffusing. So let's say this is case 1, and Na2 is the second case where we assume equimolar counter diffusion of both A and B. One minus 0.4654 or 1 minus x. Given data, we can Na1 minus Na2 by Na1 into 100 B1 is equal to 1, which is nothing but XA2 1 minus B2 point is equal to 1 into 100. So we have the values of XA1 and XA2. So we can find the corresponding values of XB1 and XB2. So XB1 is equal to 1 minus XA1, which is 1 minus 0.8 is equal to 0.2. And XB2 is equal to 1 minus XA2, which is 1 minus 0.1, that is equal to 0.9. So case 1, B is non-diffusing. So here we can use Fick's first law. So according to Fick's law, we can get the following relation, and we can have the final value dAB by delta Z into rho by m average into XA1 minus XA2 by XBM. Let's say this is equation 1, and this is for non-diffusing B. Now in case 2 into 100 for equimolar, and we can have the final value by Fick's law. We can have the following relation XBM into 100 A2, and we can have the final value dAB by delta Z whole into rho by m average XA1 minus XA2, nothing but 1 minus. So we have these two relations from Fick's law for the first case for B, which is non-diffusing, and the second case with equimolar counter diffusion. So in both the cases, dAB represents diffusivity, delta Z represents the distance between the two locations, and rho represents the density, and xa1, xa2, xb1, xb2 represents the mole fractions of A and B at different locations. Then xbm represents the logarithmic mean of the mole fractions of B. So now these two equations, we can divide equation 1 by equation 2, or basically we divide Na1 by Na2. So we can write Na1 by Na2 is equal to dAB by delta Z into rho by m average xa1 minus xa2 the whole by xbm the whole by dAB by delta Z rho by m average into xa1 minus xa2. So now we can cut all these different terms. So we can cut dAB by delta Z both the places, rho by m average in both the numerator and denominator, and xa1 minus xa2 can also cancel it in the numerator and denominator. So we can simplify and write the whole thing as Na1 by Na2 is equal to 1 by xbm, where xbm is the logarithmic mean. So this logarithmic mean of xb, we can find it as xbm is equal to xb1 minus xb2 by ln xb1 by xb2. So we have the values for xb1 and xb2, which we found in the first slide. So we can use those values and substitute those values here to find xbm, which we can obtain as 0.4654. Now substitute this in the main equation. So now we need to find Na1 minus Na2 by Na1 into 100. We can rewrite this as 1 minus Na1 1 minus Na2 by Na1 the whole into 100. So earlier we found Na1 by Na2, which is 1 by xbm. So the inverse of that, which is Na2 by Na1, we can write it as xbm. And the value of xbm, we have found it as 0.4654. So just substitute this value here. We can find it as Na1 minus Na2 by Na1 into 100, which is nothing but this is 1 minus xbm into 100, which is 1 minus 0.4654 into 100, and this is equal to 53.46, or we can round it off as 53.5. Thank you.